Okay. So, like I said, we're going to go over authentication today, and because I think that's going to be something that's necessary for a lot of your projects. So, we're going to actually try to make this a little bit interactive. I'm sure some of you have heard of this before, but what do we mean by authentication? And I'm going to pick names if someone wants to volunteer.
Um,
The
is
meaning
it
of
like,
that
oh, sorry.
is show the people uh, what a new update or new information pop up, something like that.
I'm sorry, can you speak up, I mean?
Uh, I think the meaning of that one is to help the people when using the different kind of application to get a newest update for that kind of application or newest information.
Not quite. Um, let's see. I think Ramon mentioned it in chat. You hear Ramon?
Yes, I'm here.
What is authentication?
Mm, from what I understand, if asking the user permission for them, how can I say this, for them to authorize you as the application developer to ask permission for the user for like say like their camera, their web search history, maybe tabs, something like that.
It's like providing permission. So, so whenever we go to, um, right. So, Vincent, do you want to build on that?
Yeah, so in my mind, authentication is like if you're presented with someone who's like requesting access to a certain like resource or like our website, you would need to ensure that they actually have like permission to do so, or like if they've registered or things like that.
And you have to verify that they are who they say they are, right?
Yes, that's
right. So authentication is the act of proving an assertion. Usually in the case of web applications like this, we're trying to prove that somebody is who they say they are. So just to, since Vincent was already talking, so how do we normally verify people are who they say they are in these kinds of applications?
username and password.
Right. That is the default way, is that, or at least the most common way, is that we use a username and password. So whenever someone has a username and password and they're trying to get into a system, so that procedure looks like the person approaches the client, they enter a username and password. The client then sends that username and password to the server. The server verifies that username and password. If you remember talking about sessions and how we can store data associated with particular client sessions, normally we will add that username, the user information, to the session after that to say that, okay, the session is authenticated. And we'll send back a success fail response to the client. And then any requests after that will basically have already been authenticated, and we can assume that they have access to whatever information or features that a particular user has permissions to use, right? So, all right. So typically it's just a very simple back and forth. All right. So some things that we have to take into account are different security measures. This is definitely a part of web applications that is like a focus of a lot of security work. Does someone have any ideas about how we could potentially attack this procedure.
More on the storage side, we can hash passwords whenever we're storing them.
Yeah, so that's a good idea, and that's actually, I have a few slides about that here in a bit, and I'll probably get you to explain some of these concepts. It sounds like you're kind of familiar with them. There's another way that that I have the slides are set up for here initially. So what could be another way of attacking this kind of system?
I've heard of attackers kind of catching this kind of information like mid-transfer from the client to the server.
Right, exactly. So you get this, what's called this man-in-the-middle attack, which is somebody that is basically able to pick up the username and password as they're being transmitted to the server. So the main way that we deal with that in our applications these days is just to use an encryption algorithm on all of our communications between the client and the server. And typically that is referred to as HTTPS, is the default option. I'm not going to go into the details of how to implement it. It involves getting some encryption keys and basically configuring your HTTP servers to use those keys. So getting to what Devin was suggesting, there is an alternative vector of attacking these kinds of systems where the attacker is getting access to basically where we store all of our user account information. So usernames, passwords, those kinds of things. And so in particular, this is a problem because if an attacker gets into our big database of usernames and passwords, they are, they're getting access to all those things. And not only can they authenticate into our system with those usernames and passwords, but humans are fairly terrible about using the same password over and over again and the same username over and over again in different places. So if they're getting access to those passwords, then they could potentially be cracking into a whole bunch of other systems, right? So this is a problem. And I wasn't supposed to actually show this, but Devin already mentioned it. Devin, I'm wondering, it sounds like you're kind of familiar with this. I wonder if you can kind of explain the concept behind using the hashes here.
So I don't have too much experience with hashes, but I kind of know like the general idea. So it's like basically you use a hash function to change like a plain text into like a bit string. And it's designed to be like one way. So it's really, so that way it can't be like reversed, and it's also really noisy. So like making like a slight change to the plain text should result in a really different hash. That way you can't try and like slowly or like try and reverse engineer it basically.
Right. So basically what is a secure hash is a hash function that is difficult to basically find the original text that went into the function. So there are algorithms that are basically difficult to do this with. SHA-256 is one such algorithm. There are many different others that are out there. However, there's still one potential security issue with doing this. And I'm curious if anyone has heard of this before. All right, so
does it have to do with like finding collisions between hashes?
Yeah, it does. So there are particular numerical properties of hash functions that make it so that it is potentially possible to find collisions of hash functions where you basically can find multiple different inputs that result into the same output. And so in that case, what the attacker is basically able to do is if they can find something that is a collision with that particular hash value, then they can effectively use that as a password if that is the only function that is being used. There's a technique called rainbow tables, which is somewhat effective at finding collisions in hash functions. And basically what this is a big table that is effectively able to look up potential collisions for values, or potential hash values. And that is probably a simplified explanation. You're probably better off talking to someone like Rupa, one of our crypto professors here, for a better explanation of that. But what you need to know is that leads to this technique called salting, which uses, which again still uses a hash function. But basically what we do is we, whenever we register a user and we are creating an entry in our database for their username and a hash for their password, we actually add to the password what's called a salt, which is usually a random string of characters or data that gets concatenated with the password, so that and then once we've concatenated those, then we hash it and we save that value. And so in the future, whenever we're trying to authenticate a user and they provide us with a username, we add that same salt onto the password they provide us with, and we apply the hash function and see if it matches our salted hash. And so, what is, because the salt that we're adding is random and it's going to be different from system to system. So even if we are able to find a hash collision, that isn't necessarily going to be useful for us in the next system, because the salt will be different in that system, and ultimately the hashed salt that is being stored on that system will be different. So it's another layer of security on top of this, basically, for preventing finding out effective ways to log in for stolen account information, basically. Are there any questions about how this works or why we do it? No? Okay, hold on one second. Okay. So there's another alternative authentication strategy where we can rely on an external service to authenticate. So I'm sure many of you have encountered web services where there are buttons that say, sign in with Google, or log in with Google, or log in with Facebook or Twitter, or whatever service have you. BJ, did you want to say something?
Yeah, Professor. Actually, in the previous slide, you told me some random string is taken. So is it that CRF token related to it?
Sorry, say that again.
Usually for front-end things, we'll use CRF token. Is it the same thing?
I haven't heard of that. Let me look at it real quick. A CRF token? A CSRF token?
Yeah.
let's see, is unique, unpredictable value. No, I don't think it is actually the same thing. That seems to be something that is basically a token that the server sends to the client, which it then uses to like sign or encrypt the password, I think. And then request, validates request, includes the expected. Oh no, actually that's not what it is. It's basically a token that gets sent to a client that the client basically can use to authenticate itself later, which we'll actually talk about here with this next example. But basically in that case, I think once the client has authenticated it, basically the server gives like a random string to the client, which it can then use as like a way to say that I am who I say I am later down the road. So I think that's what that is, but you should probably double check me on that.
Yeah.
Go ahead.
Yeah, fine, Professor. Thank you.
Mm-hmm. Okay. So, right. So, as mentioning with the alternative authentication strategies that we have now, where you can log in using a different service, such as Google, Facebook, or Twitter. So what might be some of the advantages of using a system like this?
Well, if you're lazy, you can just rely on like Google or Facebook's like security measures for authentication, because programming authentication can be complicated, and if you get it wrong, it could have really bad consequences. So it might just be easier to rely on like Google's services to do that process.
Yeah, exactly. I think in my slide that reveals my two expected answers, like outsourcing the responsibility is the first choice. If you're lazy and you don't want to put a lot of attention into it. What else could you potentially get out of doing it this way?
I'm not sure. I think you can get information from that kind of service for the people. For example, information about the Google or the Facebook.
Yeah, that's actually exactly right. So oftentimes whenever we do this, by authenticating through those services, we get tokens or permissions to use those services APIs to access data about that particular user on those services. A simple case would be like if you authenticated into a service using Facebook, there might be some permissions involved where you basically give permission to the service that you're authenticating into to ask Facebook to get all of your friends that you have on Facebook, and then the service might do something with that. And you could think about other potential information that you would want to get. So the way that this often works is you have a client that, let me see if I can actually annotate on top of here. I forget how this works. Okay. So you have a client that is logging in with a different service. So basically, you click on this login with Google button. It forwards you to the authorization server provided by that other service. So it redirects your website to actually go there. It sends along some data. Specifically, it sends along a redirect URI. So this is where the system you are authenticating with should actually send back the user once they've authenticated. So that'll be the final place over here. So once you're at the authorization server, you log in with your email, password, username, password. Oftentimes it'll redirect you to a place where you allow consent for access to different types of data on that from that service. If you say yes, then it will redirect the user back to the service that initiated the authentication request. And so whenever it does that, it sends along these tokens, like what we were mentioning before, that allow that service to request data or information or different features from whatever service you authenticated with. So I could potentially use my access token to look at my Gmail contacts from Google, or if or different pieces of information. I could maybe use that to look at like the documents that I have in Google Drive or something like that. If I put the permissions, if I requested those particular permissions, which is usually called a scope. And we can use this authentication process, one, to verify that this person is who they say they are, and they allow them to use our service, and then also use allow us to sort of act as a proxy to get data from that other service for them. All right. Does anyone have any questions about how this works? Generally, this process is known as OAuth, or Open Authentication, I think is what it stands for. Used to be an OAuth 1.0, but the general standard now is what's called OAuth 2.0. Any questions about how this works?
Excuse me, could you explain a little bit more? It's kind of not clear for me what's happening here.
So I'm going to try to run a demo with this, but I'll try to run through it again. So say if I want to log in with Yelp, or log into Yelp using Google, Yelp redirects me and sends a redirects me along with some data to the Google authorization servers, where I'm presented with a login prompt where I provide my username and password. If I'm asking for particular data from that service, it'll then send me to a page asking what permissions I want to give the service to access. And then once it's done through, I've given it permission and I've authenticated, then the service that I'm authenticating through will generate what's called an access token, which is like a secret token that I can give to the third-party service, which it holds on to as a way of like accessing data from the original service, but I'll also get data like their, like I'll get their Google ID number, I'll get like their email, I'll get things like that, which then I can use as a way to verify that that person, or to associate whoever is logging in with a particular account. I'll kind of, when I run the demo, I'll show you how this works and give an example. So that's what I'm going to do. I'm going to run through basically how to implement both of these types of authentication with Node using a particular package called Passport. So let me get out of here. Minimize my Discord window. Okay. So is this running right now? It's not. Okay. So I guess I'm going to run it. I have a cat in here with me. I'm going to run it first, and so you can see how it works. And then I will walk through how all of this sort of functions. So, so this is, I just have a very simple page here with a login and register button. I can also sign in with Google. So I'm just just to show you how, let me make sure that my user database is empty. Okay. So if I want to register, I can pick a username and password. If I hit register, that'll create an account for me, and I'm already logged in. So I'm logged in as this particular account. So hit log out, I can log in. If I enter the same username and password, hit log in, then I'll be authenticated as well. So, and I can store other information. I zoom in. I can try to. So I'm okay. So I can go and log out. So yeah, so you can do this typical register and log in with the username and password. You could associate other data with the username, such as address, age, birthday, etc. If you wanted to add those things. Okay, and just to give an example of how sign in with Google works, let's see if I can do this. All right, I'm actually going to open an incognito window because I've done this several times now. So back here, if I hit sign in with Google, it's going to actually forward me from my previous page, which was on localhost 3000, to Google's authentication service. So this is an external website from mine, and it's going to ask me to authenticate into Google. So let's see if I pick a, let me try to pick a, let's see, is it still, see if I can do this without ruining my life. So I authenticate, and then it comes back once I get, and it sends basically my Google data back to the service, and I am effectively logged into my application as a Google user, and it still has some set of my data. I can log out. If I try to sign in again, it'll fast forward past all of the authentication things because that's still floating around in Google sessions. So I'll just get right back in. And so you can do this kind of mechanism with a lot of different services, as I mentioned before. Okay, so how do we implement something like this? So I guess let me, so we're using a service called Passport.js, or it's more, I guess it's a library for Node. So this provides a bunch of different ways that you can basically log in. It works with Express in Node. And it has a lot of what are called strategies. And so the strategies are basically different means of authenticating through things like OAuth to different services. So if you look at Passport.js, they have a bunch of different ones of these. So they have one for Facebook, they have one for Google, Twitter. Let's see. There's Azure, GitHub, Spotify, Instagram, all sorts of different, there's a Slack one. So all of these different packages to help you authenticate through these different services. Okay, so how do we actually use this in a Node application? So again, this Node application allows me to log in through one of two ways, either through username and password or through Google. So I have some general setup here. I'm requiring Express and Mongoose so I am actually saving usernames and passwords in a Mongo database. So I'm importing Mongoose here. System standard setup, I'm connecting to Mongo. Mongoose. I'm loading in a user schema and model to use in conjunction with Mongoose to store my users. I'll give you a quick look at that. So schema, we actually have, we're storing different things in the user schema. So if we're just using username and password, then we just have username and password here. If we're logging in with Google, then we have things like Google ID, as well as Google profile, which is data involved in like my email, username, these kinds of things, as well as an access token, which allows me to go back and to use Google's APIs. I have some different tools here built into the schema. So this is this code here is actually doing the salted hashing. So I have a virtual method here for setting the password in a user schema that, given a password, it uses this bcrypt package to generate a hashed value of my password, and then that gets saved. The salt and the password hash get saved together in the database, and then if I want to compare the password I'm getting, I can use this bcrypt compare sync, which will compare the password that's passed in to its password hash, which the hash again has the salt built into it. So, okay. Again, we just have some standard setup for a Node application. We have Express, URL encode middleware, so we can get usernames and passwords. We can get Java, JSON, which I don't think we're actually doing here. We're using EJS as like a templating engine. We're setting up a session. So I mentioned before that in order to authenticate, we need to have a session that we can store like user information in once the session is authenticated. We're just using a file store for that, and we're setting up a session here. Okay, so here's where we're actually getting to the good stuff. So we have passport. So we need to initialize passport and tell Express to use it. We also need to use a particular session middleware for passport, which basically just verifies that we actually are, or which is going to enable passport to actually save user information in the session. Okay, I'm gonna skip this for a second. So this is this first strategy that we're going to use. So this is what's called a local strategy, which is just the standard username and password implementation for authentication. So basically, we set up this strategy, and we have a callback that gets called whenever we are basically trying to authenticate a user. So we get a username and password that we're trying to authenticate. We check Mongo, we look for a username, or we look for a user that has this username, and then we make sure that that user exists and that we validate the password that we receive against the hash that is in MongoDB. Again, that is happening here where we are comparing the password against the salted hash. Okay. If we don't get any of that, then we are effectively fail. Otherwise, it's a success, and we send along the user to store in the session, and we are authenticated. We're telling passport to use this particular strategy for logging in. We have a post request here that we handle that is basically creating a user whenever we are receiving a post request from that HTML form. So we get the username and password from the post body, and then we create that user in the database. And then and then whenever we want to handle logins, we have an express post route for login that will have username and password put in into the request. And then we just, for the callback, we say it's this passport authenticate function that will manage the username and password and make sure that everything works. And then if we have success, then we just redirect back to the front page. Otherwise, we redirect to back to the login page here. So it ends up being relatively simple, but there are quite a bit of details here. I did want to implement this so that people could have something to maybe start with, and I will have this code up after class so that y'all can access it. Is there any questions I can answer? I know that there's a lot sort of going on here. Are there any questions that people have at this point just about supporting username and password authentication? Okay. So I'll move on showing how the Google authentication works. So whenever we want to set this up, we need a couple things. The first thing that we're going to need is we have to tell Google that we are basically that we need to register our application or website with Google so that we can authenticate. So to do that, you want to go to this console.developers.google.com, which is like the developers console for Google. You'll want to create a new project here. So you'll say new project. I already have quite a few set up here. So I'm just using this course auth example. I guess I could actually walk through creating a new one. So let's just say new project. So this is just project. Go ahead, create. All right, and I want to swap to that project. So okay. So I want to create, when I'm in this project, I want to create credentials. So I need to create credentials for my application. So I wanted to use this OAuth client ID. Credentials is what I want to create. It's going to make me configure the consent screen first. So the consent screen is basically the thing that I log in with and makes me authenticate into Google and give my permissions. I'm going to say it's external, so it's available to anyone with a Google account. So I create. So I give an application name. You can give them a logo, which will display. You can give them a user an email that they can contact for support. And these are some scopes that, so again, this are things that your app will be asking permissions to look at. So I should be able to look at the user's email information about their profile, as well as what's called their Open ID, which is just part of this OAuth protocol, I believe. So, and then so authorized domains. So you have to tell Google which domains you actually want to support doing this authentication on. So if we were doing something on EC2 or on some sort of service that you controlled that had a domain, you would put in that domain name here. We're just doing local host testing. So I'm just going to say host and I should do a port. Let's see, you must not specify a protocol. Okay, so yeah, just the domain. So, and then you would do I do this before? Well, let me do this with the other project. Maybe it's because I already have that. All right, I'm going to go to the other one. So domain, so let's see, auth consent screen. Let's see. Oh, I actually set this up with a EC2 domain. So you might have to actually have a working domain name to set up this OAuth screen. However, I was able to like actually set up the credentials. So whenever you set up the credentials, it's basically going to ask for a name for the client application that is going to be accessing the Google Authentication service. You need to specify the URL that you'll be accessing it from. So in my case, I'm just doing localhost 3000. And then, so again, you need to provide this callback. So the callback is where Google is going to call once I've authenticated with the information about my user account. So let's see. So once we have all that, we hit save. And when we hit save, it'll generate a client ID, which basically just identifies what our application, and then a client secret, which is supposed to be a token that we only know about and verifies that this application is who we say it is. Okay. So whenever we are setting up Passport to use Google, we are using that key information and the secret that we just generated via Google to configure the strategy. And we provide a callback URL to tell Google where to call us back. It has to match that URL that we mentioned before to Google. And here we get a function callback for whenever Google gets back to us with basically an authenticated user. So we get this access token, which enables us to access the Google APIs if we want to, a refresh token. So this is something I think we can actually use to like refresh our authentication with because it expires after so long, or to refresh the access token, I believe. We get the profile. So the profile has a lot of data in it. So about the user. So let's see. So once we create this user, we create this user in our database using this finder create, and then I'm adding all of this particular data, metadata to that user. So the Google profile data and the access token we go ahead and add. And we use the Google ID for identifying it. So just to give you an idea what that looks like. So this is a zoom in control shift. So this is an authenticated, this is an entry in our database of users for an authenticated user that I signed in with. So we have the Google ID and the Google Access token that we got. But if I want to see like who it is, so again, this is a Google ID, display name, and then there's a whole bunch of different data here for where to represent this particular user account. So even it has things like my gender in here. So we can get all of that as an initial profile information. Let's see. think there should be even like a profile. I think, yeah, this goes like my Google Plus profile, which is kind of defunct at this point. But anyways, so we get all the data and we save it to support. We get all that data and we save it to basically represent the user in our system so that we have a record of it existing. If we wanted to have other data associated with our user, we would add it to that user object within our own database. So just to show you the paths that we need to do. So we tell Passport that we want to use this Google strategy. So this button that you see here on the front page of this website that I have, the sign in with Google, that links to this auth/Google GET request. So once my server gets this, it calls passport.authenticate with the Google scope. And this is the scope that's necessary to tell Google that we want to authenticate into Google Plus, basically. And then it handles it from there. So it will redirect the client to users' authentication, to Google's authentication pages, which we then go through all of our process where we type in our username and password, select permissions, yada, yada. So once that happens, we get back to here, our callback that Google is redirecting us to. We call passport.authenticate, and then with a failure redirect, let's see. So, so at this point, we should have more data that's coming in from Google and the redirect that they initiated. And then this will go ahead and call this validation code here, which again looks up or creates the user, the Google user in our own database. And provided all that goes well, we redirect back to the front page. And so once we're authenticated, we have this .user object that is in the session, which we can access through rec.user. So here I'm just rendering the front page using EGS. And so as you can see, I can check if the user is undefined. If there's no user there, then I'm just saying that we're not logged in. I show the login and register buttons, as well as the Google authentication button. If we are logged in, then we can check to see if we're logged in with just a standard username password, in which case I just say logged in with the username. If it's Google, then I look up the Google display name and display that here, as well as provide a logout button. The logout button just goes to this path here, which basically calls logout on rec, which tells Passport to basically strip the session of the user information, and we are effectively not authenticated anymore. So there's a whole lot there. And I will make this code available. Does anyone have any questions that I can answer about how this works? So people able to follow this? I'm hoping you were able to. Kind of went through it quickly. The recording will be available if you're interested. There was one part that I skipped over, which is this passport.serialize user and deserialize user. So this is basically a mechanism that's used for saying how we're saving the user in the session. So we're only saving the user ID in the session. So that's what this is saying. So so if we have a user, how do we save it in the session? Well, we just respond with user.id. and that gets saved in the session. Whenever we are loading up a session, we get a request, and we want to put the user object in the request object in our express parameters, then we have to deserialize that. So given the user ID, we look up the user out of our database, and we put that into and back into the request objects here. So if we want to, right, so if we want to access the user object, that deserialization function is what's putting that here based on the user ID. So again, that's just a small detail. But this code should be fairly useful for you as a way to get set up with authentication in your projects. If you run into problems with it, let me know, and I can try to help you figure out how to figure out your issues. So, and for those of you who don't know, there's a link to the source code for these demos on the front page of Canvas. So it'll be in there here shortly after class. So yeah, so that's most of the demo. If you want to learn more about Passport, you can go to Passport's website. There's some documentation as well as some walkthroughs on how to get things set up. That's pretty much all I have for today. I'll hang around here for a few minutes if people want to ask questions about things or discuss project, anything about your projects. Otherwise, that's class today. So.